한 번만 산다. 한 번만 산다.
Убирайся отсюда. Убирайся отсюда.
Alright, that's the best editing that I can do. I hope you like it. So in this video, we are going to talk about a 2D momentum question. And again, it's not required in IGCSE or IB Physics, but I hope you find it interesting and challenging, especially for those who like physics. So here the scenario you can find on the note, and notice that we basically have two maps. So one is the plane and Donald Trump and Kim Jong-un, which has a mass of 1,000, so I call it M1, 1,500 kg. And then the other one is Putin and the bird, which has a mass of 150, so let me call it M2. And the plane is moving towards right, so in this case it's like literally along the x-axis. So U1 we can say is 15 meters per second. And for Putin and the bird will be moving towards the plane at an angle that is U2 with 30 meters per second. And so the angle is 40 degrees to the horizontal. So in that case, you may want to annotate on your diagram that this is 40 degrees. Although it's a challenging question, I still want all of you to try it. So the question asking you the horizontal speed of the plane. And so one thing that I should have mentioned more precisely on the question is that eventually they would be sticking together. Okay, so they are not splitting. So they will, like since it's like a counter attack, so they kind of go on together. And that's one thing. The other thing that is when you try to calculate the horizontal motion, you only need to care about the horizontal physical quantities. So that is to say, for U2, because there's an angle, you only account for its horizontal component. So that's the hint for you. You may want to try, pause the video now and try yourself.
2,000 years later.
Alright, so let me try it out. First of all, we of course will just be recalling the conservation of momentum equation. Okay, mu on one side, mv on one side, 1, 1, 2, 2, 1, 1, 2, 2. Because I think we already know everything already. So for M1, we've got 1,500. For M2, we have 150. Right? And then for U1, it was 15. So multiplied 15. And then U2, okay, U2 is a bit tricky because you have to take the trigonometry to consider component. And if you try to do that, you'll find out it should be cosigned 40 degrees. Okay? And if you cannot really see it, try to draw the triangle. So this is 30. Alright, and you want to find out the horizontal one only. Okay? And so this is the angle, and so yeah, that would be cosine 40 degrees multiply 30. Here I think I have to write again for more space. So multiply 30 cosine 40 degrees. And then on the right hand side, since I said they will be sticking together, so they will be sharing a common velocity, common final velocity. So I'll put it as a big V here, or you can do VC if you want to, common velocity. Oh, one thing that I almost forget is because they are going in the opposite direction, right? Just like the previous video. And so one of them has to be negative. And so let's do right hand side is positive because it's more intuitive usually. So here for Putin, that initial velocity 30 cosine 40, I should put a negative here. Okay, and I think the rest should be good, and you should be able to find this common velocity using calculator. Okay, so eventually VC should be positive 11.547. So I guess I'll run it to 2 to 3 sec fix, so let's say 11.5 meter per second. So this is the direction that is going to the right, when they both collide and sticking together. So they will continue to move to the right. And in fact, I want you to try harder. What about the vertical motion then? Can you try to calculate what happened to their final vertical velocity? It should be very similar to the one that is horizontal. So try it yourself and pause the video now.
A few moments later.
Alright, so for vertical is very similar, like I said. So once again, I would like to quote the conservation of momentum again. So this is the equation, and then let's not forget the plane was moving horizontally, so vertically there's no movement. So for u1, this time is actually 0. So I don't even bother to put up m1 because it's going to be 0 anyway when you multiply 0. As for u2, then it's non-zero because remember we took the component. So this time, of course, we have the mass the same as 150, but then for the vertical movement is going to be downward. So let's say we take downward as positive, then we should have 30 sine 40 degree this time. Okay, because you should be able to see that this is this y component, vertical component, should be sine 40. Okay, and then again, since they will be sticking together, so no matter horizontally, vertically, it's still sticking together. So we would have, similar to what we did, the mass add together multiply with a common velocity. So to distinguish, maybe it's better if I specify this as x. Previously for horizontal x-axis, this time it's going to in the y-axis. So just make it clear for representation. So VCY by calculator should be something like 1.75305. Okay, and again I'll run it to 3 sec fix, so 1.75 meter per second. And again this time it's positive, so like how we define it should go downward. And so eventually, if you still want to push harder on knowing more about physics, then what I would say is you can actually calculate the resultant final velocity, because right now 11.5, this one, and 1.75 are just the vertical and horizontal component only. If you want to find the total one, which is going in a certain angle, then imagine you have a vector that is going this way and a vector going this way, 11.5 and 1.75, then you should have a resultant vector that is going in this direction. And so in order to calculate the magnitude, it's very simple. Just use, guess what, Pythagoras theorem. So you could say that VC now is the total one, so I don't give x or y, so just VC, common velocity, should be the square root of 11.5 square plus 1.75 square. And so by calculator, it should be something like 11.63. So I'll run it to 11.6 simply. Okay, and obviously you can tell that the vertical motion doesn't really affect much because it's so small compared to the horizontal one. So that's why it doesn't change so much. It was 11.5 horizontally, and now in total it's just 11.6 altogether. And that is the final velocity. And if you really want to do one more thing, that is calculating the angle, this is really the last thing. Then what you can tell from this diagram is that you can use tangent to calculate, right? So tangent theta is going to be 1.75 over 11.5. So again, using your calculator, you can find the answer. So arc tangent here will give you about 8.6 degree. Okay, so almost going horizontal, but then just slightly down to to the downward direction, 8.6 degree. I hope you enjoyed this video. If you do so, please hit the like button and subscribe to my channel. And by the way, for these two dialogue bubble, feel free to fill in anything that you find hilarious. And please share with me if you thought of anything that is interesting. I'll see you again in the next video. Bye.